So
for the likelihood it's 400 feet, and if you want to do a desert, I don't think that 400 feet is going to be devastating.
You had to know, had to calculate it. All right. So first, it's up to you how much of this you want to write down. I have a couple slides that are really just explaining what a radian is. Not because that's what I'm going to quiz you over, but I'm trying to get you to wrap your mind around this other measurement. You know, degrees are actually a pretty arbitrary thing. We've said a circle has 108 or 360 degrees, but no real reason other than the fact that that's what we told you, right? And we base everything off that. A radian is more concrete. If you have a circle with a central angle, so that means this is at the center of the circle, that cuts off an arc equal in length to the radius. So this is the radius. The arc is the part of the circle in between our angle. That's called S, usually, the arc. So our angle here, a radian is how big that angle has to be so that the radius and the arc are the same length. So if my radius is 3 inches, how big does my angle have to be so that the distance on the outside of my circle is 3 inches? Okay, so that's what a radian is. To find the radian measure, then, you have to do S divided by R. That means arc length divided by the radius. So, for example, if I tell you you have a central angle theta in a circle of radius 3 centimeters. I have a circle, angle coming out from the center. The radius is 3 and it cuts off an arc of 6. What's the radian measure? So we just said you just have to take your arc divided by your radius. Our arc length is 6 centimeters. Our radius is 3 centimeters. So 6 divided by 3 is 2. What happens to that centimeters? It cancels, and there's no unit left. That's a radian. A radian is a real number. It is unitless. So from here on out, anytime I see a number without a unit beside it, I am assuming you are talking about radians. So if you write 20, if there's no degree symbol, that's 20 radians, which is very different than 20 degrees. So up until now, I keep telling you, you have to put a degree symbol and I'll write it in, but now I have to start taking off because it means something different. Okay, so anytime you don't have units, that's radians. So if I'm going to have two different ways of measuring my angles, we need to be able to convert between them, right? We have inches and feet, and we know there are 12 inches in a foot. So if I'm going to have radians and degrees, how are they related? So let's look at this. This is kind of my motivation. In a full rotation, so I'm saying if you take a point and you go all the way around your circle, my angle, I just said, is S divided by R. If you go all the way around, the S is the entire distance around the circle, also known as arc length. If all the way around, that's the circumference of a circle. How do you find circumference of a circle?
Probably like pi over 2.
2 pi r is circumference, or distance around a circle. You may have seen that before, perhaps.
I have just made that up.
Okay, in degrees, if I go all the way around, that's 360 degrees, right? We just said up here, my angle is 2 pi r divided by r. What happens to those r's? if they're on top and bottom.
Oh, we can as well.
So 360 degrees is 2 pi. So all the way around the circle is 2 pi radians. If you want to reduce, divide them both by 2. So 180 degrees is equal to pi radians. This is our conversion factor. That's how we go back and forth between them. All right. So now we can start doing some conversions. If I ask you to change 45 degrees into radians, we've done conversions before, right? We said I have 2 hours and I want to change it into minutes. And we said, okay, well, I know 1 hour is 60 minutes. And why did I put the hours on the bottom? To cancel them. So if I'm going to go to degrees, I have to put degrees on the bottom. So we use our conversion factor. We know 180 degrees is equal to pi radians. So to get my degrees to cancel, the 180 is on the bottom, so we multiply by pi over 180. So when we do that, if you type the whole thing in your calculator, you get a decimal because it multiplies out the pi. What I want you to do is put 45 divided by 180 and give me that in fraction form. And what does that give us? 1/4. Then we put the pi back. So this is pi over 4. So 45 degrees is equal to pi over 4 radians. Right. If I have 450 degrees, same thing every time. If I'm turning it into radians, multiply by pi over 180. So 450 over 180, what does that reduce to? So we'll say 5 pi over 2. Okay, if I said negative 78.4 degrees, still just multiply by pi over 180. And we get
28 divided by 225.
I had 98. 98 pi.
Yeah, negative 98 divided by 225.
Sorry, I misheard you. All right. Sometimes they may not be nice. If I said 21 degrees, 43 minutes, and I asked you to turn that into radians. Okay, we still have to multiply by pi over 180. When I put this in, I have to do 21 plus 43 over 60 in parentheses. And if you divide that by 180, what happens when you try to turn that into a fraction? It doesn't give you. So we have this decimal that still has pi, but it's kind of silly to approximate that. So in this case, I would say go ahead and multiply out. So just hit, you have that decimal, hit times pi on your calculator and go ahead and get the equivalent. So 0.379. So you can keep pi in your answer, and most of the time we want to, but if it's ugly and you have to round it anyway, go ahead and multiply out the pi. Any questions there? So we should be able to go the other way as well. If I said pi over 6, there's no degree symbol, so this is radians. If I want to turn that into degrees, what would I multiply by? 180 over pi. This time I need the degrees on top because I want degrees. Pi on the bottom, so then those pi's cancel. We just have 180 divided by 6, which is 30. All right, if I write this, my answer is wrong. Why?
You do radians.
30 degrees and 30 radians are not the same. All right, so 4 pi over 3. If I want that in radians, we multiply by 180 over pi. Pi's cancel. So we have 4 times 180 divided by 3, and we get
240.
All right. Negative 4.5. It always seems like when I put this, people assume it's degrees because there's not a pi in it, but it's not because there's no degree symbol. So it doesn't have to have a pi to be radians. So you're still just multiplying by 180 over pi. So if you do that, the pi's don't cancel this time. So negative 4.5 times 180, that's negative 810 over pi. So you could say negative 810 over pi degrees. Or if you did choose to go ahead and divide out the pi, it's like negative 257.831 degrees. So you could write it either way. So the pi doesn't have to cancel out. Are there any questions about going between degrees and radians? Okay. So next, we are going to talk about the unit circle. So when I say the unit circle, I am talking about a circle with a radius of 1 that's centered at 0, 0. So, this is like the x and the y axis. You don't have to necessarily draw that on there, but that's the x and y axis, the point 0, 0. Next week, we'll do ordered pairs on here. Right now, I just want you to talk about degree measures. So if we're starting, this is like my 0 degrees. These angles I have marked represent the common angles that come up. Think about your hand trick. What angles do we have?
40, 45, 60, 90.
Okay. If I jump down here, this would be 180 degrees because it's a straight line. All right. Now we have to think a little bit more to get these other angles. Now remember, reference angles were distance to the x-axis. So this is a reference angle of 30. It's 30 degrees to the x-axis. This one is also 30 degrees to the x-axis. And this one, and this one. So those are all my angles that have a reference angle of 30. These are all 45 degrees from the x-axis. These angles are all 60 degrees from the x-axis. All right, so when we worked with these, we said, well, here's 180. This is 30 degrees away. So if I back up 30, what is it? Just like when we found reference angles. If it was in the second quadrant, we subtracted from 180. Okay, what's this one going to be? 180 minus 45 is 135. This one would be 180 minus 60 is 120. Okay, in the third quadrant, these are bigger. So it's 180 and then another 30 past that. So that would be, 180 and another 45. So 180 plus 45. 180 plus 60. So it's 180 plus 90. Okay, if we go all the way around, 0 degrees, 360 degrees, those are coterminal. They end at the same spot. So how do we get these angles in the fourth quadrant?
You can add it to 270 or subtract it from 260.
To keep with our reference angle theme, that's always from the x-axis, so let's subtract from 360. So 360 minus 30, 360 minus 45, 360 minus 60. If you want to check at the end if you did it right, look at your angles. As you go around, they are just growing, right? As you travel further. That'll help if you accidentally flip a 30 and a 60. You'll catch it then. So they should just be increasing as we go around. Now, I want to add the radian measures to these. We've already said to get the radian measure, you have to take your degree and multiply by pi over 180. So 0 times pi over 180 is still 0. What's 30 times pi over 180? 30 pi over 180, 30 over 180 reduces to, so that's pi over 6. All right, 45 times pi over 180.
Pi over
60 times pi over 180.
Stones.
90 times pi over 180. What I want you to do is take a minute. So what do we get for 120?
2 pi over 3.
135.
3 pi over 4.
150.
5 pi over 6.
180.
Pi.
210.
7 pi over 6.
225.
5 pi over 4.
240.
4 pi over 3.
270.
3 pi over 2.
300.
5 pi over
315.
7 pi over 4.
And 330.
11 pi over 6.
All right. 360, if you wanted to, you could say that's 2 pi. 0 and 2 pi represent the same place. So we have all of our degree and angle measures, or degree and radian measures on here. Now, you could certainly, if I gave you a blank one of these next week, you could probably figure it out. It would take a second. You have to calculate them as we go. But let's see if there's any shortcuts. Look at all these lines that I highlighted yellow. We have pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. What do you notice? They all have a 6. Anytime our reference angle is 30 degrees, our denominator will be 6. Right? If I look at my green lines, my 45s, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. They're all over 4. So 45s always have a 4 in the denominator. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, all of those have a denominator of 3. So you could fill in all the denominators just knowing your reference angle. Now let's look at the numerator. Is there any pattern there? So if I look in the first quadrant, those are just pi over something. Look at the second quadrant. How is the numerator related to the denominator? It's 1 less. 5 over 6, 3 over 4, 2 over 3. So if we knew those denominators, we just subtract 1, now we know our numerators. And that's from the reference angle. Now in degrees, we did 180 minus 30 to get 150. So it's doing pi minus pi over 6. Pi minus pi over 4. So that's why it's always just 1 less. In the third quadrant, we always added our reference angle. How are these numerators related? It's 1 more, because you added your reference angle. Now the fourth quadrant is probably the least obvious, but there is still a pattern. Think about how we did the angles. We did 360 minus our reference angle. So this is like 2 pi minus our angle. So it's double minus 1. 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. Right? And it could even work here. Actually, this follows both. It's 1 more, and it's double minus 1. It fits in between the two. My reference angles of 90, so this is like 0, pi over 2. This would be 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 was reduced to 2 pi. So there are tons of patterns going on here. So if I ask you to fill out a circle, you don't have to pull out your calculator and calculate each piece along the way. We just use those patterns to help us. Now, this is the part where I kind of want to take it slow. I want you guys to get comfortable with radians. I don't want you to automatically think, oh, that's radians, I need to change it into degrees and work from there. You can, but it's an extra step. We want to get to the point where we're used to seeing these radians and we don't automatically grab our calculator. So that's why I am going to take this a little bit slow. I'm going to do one example to finish, and then Tuesday, we're going to practice with the unit circle some more and just work a lot of problems involving these radians just so we're getting more comfortable with them. So, last examples for the day. All right, when I see sine of pi over 3, pi over 3 is like what degree measure? 60. So when this is just a hand trick. This is the same as saying, what's the sine of 60 degrees? And so we get I ask you for the tangent of pi over 4. Pi over 4 is just like 45 degrees. So radical 2 over radical 2 is 1. So these are the types of questions we're going to have on our next test. The same ones we just had on our test. The only difference is I'm giving them to you in radians. What if I said secant of 5 pi over 6? So you can automatically think, oh, that's 150 degrees, and work from there. You could also just think quadrants and reference angles from the radians, whatever you're most comfortable with. When I look at this, I think, well, the numerator is 1 less, so I know what quadrant is that? 2, which is the same as 150. If you change that, it's less than 180. Reference angle, when I look at it, it's pi over 6. Anything over 6 is 30 degrees. In quadrant 2, sine is positive, so secant would be negative. Okay, secant's the reciprocal of cosine. Cosine of 30 is radical 3 over 2, so 2 over radical 3. So same work as before, quadrants and referencing. If I ask you for the cotangent of 5 pi over 3, what quadrant is that? So in quadrant 1, everything's just pi on top. In quadrant 2, the top's 1 less than the bottom. Quadrant 3, it's 1 more than the bottom. Quadrant 4 is double minus 1. Reference angle. Anytime I see something over 3, that is,
60.
okay, in quadrant 4, cosine is positive, so cotangent would be negative, okay? So then, if I think about tangent of 60, would be radical 3 over radical 1, so cotangent would flip it, which turns into, so the exact same calculation we had in the past. It's just the problem is given to you in a different measure to start with. Any questions?